All right, so now we are going to be talking about learning target 3-4, which is about ionic compounds. We've already learned about covalent compounds, and now we are going to start ionic. This is our last learning target in this unit. So, a covalent compound was when we had two nonmetals that were bonded together. An ionic compound is when we have a cation and an anion that are bonded together. A cation is a positively charged ion that has lost some of its electrons, and an anion is the exact opposite. So that's the negatively charged ion that has gained some electrons. A way I like to remember cation versus anion is when you write cation, it has a T in it, which is like that plus sign. These bonds are formed when a cation transfers its extra electrons to an anion. These bonds are often formed between a metal and a nonmetal. So as you can see here, we have Na and Cl, which makes NaCl, which is table salt, and Na is positive. It has lost one of its electrons, and our Cl has a minus, which means it has an extra. So by Cl giving its electron to Na, they become NaCl. Our first step in forming an ionic bond, we are going to use our example Mg and Cl, which is magnesium and chlorine. So what we have to do is we've drawn the Bohr models here. Okay, so we have all of our electrons for both of these ions. Then, the reason that we crossed out our two valence electrons for magnesium is because it's easier to lose 2 than to gain 6. So magnesium, to have a full shell, is going to lose 2. So that's going to be that plus 2. Now chlorine, on the other hand, it has 7 valence electrons. And we drew this purple one here because it's easier to gain 1 than to lose 7. So this is going to have a -1 charge because it's going to gain an electron. Okay, so this is our ions. These are our ions right here. We have that magnesium 2 plus because it's easier for it to lose 2 electrons than to gain 6. And then we have our chlorine, which has an extra electron, so it's going to gain 1 electron. Next, we have to balance out our charges. So we've got our magnesium 2 plus and our chlorine 1 minus, or chlorine minus is fine. We have to balance these out. What that means is we need to either add or subtract our anion to make sure that our charges cancel out. Right now we have a 2 plus charge here and a 1 minus charge over here, but we need our net charge to equal 0. Alright, so in order to balance out that plus 2 charge, I have to make 2 Cl minus 1 charges to make them cancel out. So I have my 1 magnesium here, and now I have 2 new chlorine ions. Next, I have to write the number of each ion as a subscript, which is that tiny number. So I have 1 magnesium, and we don't write a 1 subscript. And then I have my 2 chlorines, 1 and 2. So something about transition metals. Transition metals are that big section of the periodic table. You might remember it as the D section when we were doing electron configurations. These transition metals do not have set charges. Some of them can form a +2 or a +3 ion. It just kind of depends. Now, if we're looking at the formula for a compound with chromium +2 and chlorine, then we have our chromium +2 and we have our Cl minus. Then we need another Cl minus, just like our other problem, to balance out that 2 plus. We need a 2 minus. Now we have our completed formula because we have 1 chromium and we have 2 chlorines here. Next, we're going to pause the video and write the formula for a compound with chromium 3 plus and chlorine. So it's the exact same thing as we did before, but to balance out that 3 plus, we now have to write 3 chlorine ions. So that 2 that we drew earlier is going to become a 3. Now, we talked very briefly about polyatomics. So polyatomic ions are charged chemical species, or an ion in this case. Here's a chart of them right here. They are composed of 2 or more atoms that are covalently bonded. This means they're going to be 2 nonmetals bonded together. And when we include them in our ionic notation, we need to have a parentheses around them, and then our number of ions to go here. So we treat them exactly like a singular atom, but we have to add those parentheses so we know that those are bonded together. Now go ahead and write the formula between phosphate and magnesium. Now this is not just phosphorus, so I'm going to go ahead and give you the formula for phosphate. It is PO4, so we got to put that in parentheses with our 3 minus charge. So we have a 3 minus charge on our phosphate, so that means to counteract our plus 2, we almost have to find a common multiple. So if I add another plus 3 and another plus 2, that just means I'm going to have a plus 4 and a minus 6. That still doesn't balance out. So in order to balance it out, I need to add another magnesium, which will get me to a plus 6. Then I can have a plus 6 and a minus 6. So in order to balance out my equation, I need to have 3 magnesiums and 2 phosphates. So for the charge on our transition metals, it's going to depend. A lot of our transition metals can have different charges. For example, copper here can become a plus 1 or a plus 2, and iron can become a plus 2 or a plus 3, and there's a lot more that are similar to this. But right here are a couple of charges that do not change, so you're going to want to write those down. All right, that wraps up our video notes. Really nice job. We are going to do a lot more walkthroughs with this kind of stuff in class, but feel free to write down any questions you may have, and I will answer them at the beginning of class on Monday.